Welcome back to our Eternity series. This is actually part 4 of 7. Let's take a quick review of our first 3 parts. So part 1, we had our story of the gift of sunlight. And then part 3, we had our story of the gift of music. And sandwiched between the two is part 2, and that was a story of growth. And in all these stories, we were wrestling with the difference between the discrete world and the continuous world. Or you can think about it as like a snapshot versus a movie. Well, we actually only have one main story to go. It's just that this main story has 4 parts, and the first part will be in this video. And each one is going to kind of build on each other. And in all of these, we're going to continue to wrestle with the same thing. Wrestle with the discrete versus that continuous. And that's just something that is just so fascinating that we can't get away from. And in doing so, we're going to take a little bit of an off-road experience to get there, because sometimes it's that off-road experience that allows us to see things that we normally wouldn't see. So I'm going to ask you to use your imagination in order to get there. It's going to challenge you a little bit, but I know you're up for the task. So we're going to start by rethinking on how we do math. Okay, Jack, I'm imagining a number. What number am I imagining?
36.
No. Okay, I'm going to imagine another number. This time I'm going to give you another clue. I'm changing my number than I did before.
2.
Oh, that guy's smart. Okay, Jack, I'm going to change my number again. I'm going to imagine that number. What number am I imagining?
1.
Okay, now I'm changing my number again, Jack. What number am I imagining?
0.
See, now how come you got 0 the second time, but you didn't get 0 the first time?
Well, I followed the pattern.
You followed the pattern. And so, you know, that number 0 is kind of a weird number because we think it's a number, and yet it really is something that we didn't even have as math people for a long time. And we actually had to invent that guy because really we had to invent a number that assigned something to nothing.
Yeah.
And we're so used to it now, but when you first start out, it's like, okay, we don't see it, so it's not there, but you could follow that pattern. So, do you like going off-road? I know you're a four-wheeler.
Yeah.
You're an off-road guy.
Oh, yeah.
I want to take our math off-road. And in order to do that, we need to rethink how we do math. Can you rethink math a little bit?
I'll try.
Okay, good. Because we often think of math maybe in an old way, maybe a calculated way, but what we're going to do today is we're going to think about math in terms of action, because we like action. When we go off-road, it's all about action, and so in order to rethink our math, we need to think of math in terms of action. So are you ready for that?
Yeah.
All right, we're going to start really simple, and I'm going to do some addition. So I'm going to start with that number 0,
Yep.
and then we're going to add 1. So 0 plus 1.
Seems simple.
Okay, that's 1. Yep. And we're going to add another one.
There's 2.
2. I think that works. So no, we don't need to change our math. Our old math works just fine. In fact, we can even reverse that. We know subtraction. So if we take 2 minus 1, we end up with
1.
Okay, right? And if we take 2 minus 2, we end up
0.
with that 0, right? Yeah. Why don't we get that something here? This is now our new number 0. Okay, so we just identified a number 0, and we took 2 away, and we end up with 0. So now what happens if we've got 2 and we want to take away 3? How do we do that?
Well, we take these 2 away.
Yeah.
And
But then
we need something over there.
Something over there. So we're going to have to rethink math. So let's rethink math, and we're going to bring in this guy here. And what we're subtly doing here is we are changing our ideas of numbers, of just abstract things that are out there in space, to something that's like on a line. They're ordered. They're ordered, and we've always thought about going from 1 to 2 to 3 to 4, and we backed up and we said, well, we need a starting point, so we came up with this number 0. But then if we start taking away more than what we have, even though in the physical world we can't, we imagine this direction going in this other way.
Right.
And then, like, what would you give a name to that guy right here?
Negative.
Negative, yeah. So this way is going negative, that way is going positive, and so we've got numbers, quantity, and we've got direction as far as which way we're going on this number line. And so that allows us to take away and do subtraction. So now we've got addition, we've got subtraction. So let's go to multiplication. And so with that, why don't we bring in some new guys here. All right, so we've got this little multiplication problem going on. And what kind of problem does this look like to you, Jack?
It looks like 2 by 2.
2 by 2. So we can think of it as 2 squared. We can think of 2 by 2. We can think about it as repeated addition, 2 plus 2. They all get us to the number 4, don't they? And if we maybe go this way, now we've got
2 by 1.
2 by 1.
2 times 1.
Yep, 2 times 1, 1 times 2. They get us the same result. We don't have a squared, but we still have repeated addition. It still works. So now if I would say, well, what happens if we have 1 times a negative 2?
Then you have negative 2.
Negative 2, but how do you show that? I know you're a smart guy, you figure that out, you've been trained, but we need to think about our math to, like, if you're going to explain that to, like, one of my grandkids who doesn't know about negative 2 yet, we got to show them because they can't see it. So we're going to have to rethink our math. And so let's bring back our 0 again. And we're going to take, let's say, 2 times negative 2. So we can maybe stack those guys up there because we know that that's 2 times 2. So we're going to rethink how we do multiplication. And it's kind of like how we rethought subtraction and addition. We're going to break it up into 2 parts. We're going to talk about the number, so 2 times 2. So if you want to think, you can think about that as distance or quantity. And then we're also going to think about direction as far as which way we go. And so if we have 2 plus 2 times a plus 2, we have 2 positive things. So the number 2 times 2 is 4. And we have 2 positives, and our default direction is just going in the positive way. So our number is 4, and then our direction is positive, so we end up with a positive 4.
Right.
And if we have 2 times a negative 2, again, our distance is 4, but now our direction is a positive times a negative. And then that's going to reverse us around into this direction. And we're going to have a negative 4. And help me think through then, how do we solve a negative 2 times a negative 2?
Well, it'd be going back this way towards the negative direction, but then we come back towards the positive direction.
Right,
again,
because we have 2 negatives. So we're doing a half a turn and then another half turn, and that gets us right back to where we started from. So we end up on the positive direction and we have 4. So that helps kind of explain, because that is something that we've learned over time, but that's not an intuitive concept as to why a negative number times, which we can't imagine, which, I mean, we have to imagine we can't see, times another number we can't see, we have to imagine, turns out to be a positive number.
Right.
But thinking about it in terms of multiplying by a negative number as a half rotation, well, then it makes sense, because now we just have 2 of those half rotations, and we end up back where we started from. So I think that's pretty cool. So now this is great, but really we're just talking about half turns, and we're on this line, this number line, and that's really not off-road.
Right.
And I can see you're getting your 4-wheeler ready to go, and you're wanting to go off-road. So to do that, we need a little bit of help. And in our family, we used to play the game Twister. And so let's bring out the old Twister game. And this is going to age me a little bit, but if you look at this, and what we looked at, let's look at this blue dot right here, and we're pointing in this direction. And now all we're worrying about is the direction part. We're not worrying about the distance part. But before, what we did was we did a half turn. So we took that pointing device and we did a half turn there. So that's like multiplying by negative 2. And then if we had 2 negative 2s, that's where we got the full turn, and we kept going in that same direction.
Back to the positive direction.
Back in the positive direction. So, but we can see that's a line. But you know what? Why not think about going off-road, off that number line that we love so much, and just pretend that there's something over there? Let's build this thing. Let's build this thing. So what we're going to do is we can take let's just use these gray numbers here, and we've got orange is 0. Okay. Actually, why don't we'll use greens. They'll be smaller. And then we'll put in our 0 in between there. So here we got +1, -1, 0. And before we were doing this half turn, but we want to do like Twister, a half of a turn. So we're going to land right here. We can make room for that guy. And we land on something. And remember when we talk about rotating, that's like multiplying. So we're going from a +1 multiplying by something which produces a quarter of a turn, and we land on that, and then we do that again, and we go get here.
To a -1.
Yeah, it's a -1. So whatever this number is, we basically multiplied by it twice.
Yep.
1 times that gets us there. Then we take that again by itself, rotate it there again. And so we've got, if you call it x, we've got x times x equals -1, or x squared equals -1. So what's x?
I don't know. We have to imagine it. It's here.
Yeah, it's not a real number. And we think of real numbers as things that measure distance. And so every number we think of that measures distance is either rational or irrational, because every line on here will measure distance. But this thing over here doesn't work because we can't take a number times itself and equal -1. So we're gonna have to imagine a number right there. And let's just call that our imaginary number. What do you think about that?
Seems fitting.
Seems fitting. So there we have it. There's our imaginary number. One thing I appreciate about math is that it is permanent. Once we create it, or perhaps discover it, it is here to stay. Have you ever thought about this rather profound idea? Sometime in history, we decided that having nothing is a number, and we declared it number 0. This was a permanent change in human thought. That is the neat thing about math, is that once an idea sticks, it is permanent. Okay, that's the story about math. What about the story about us as people? Have you ever wondered whether we humans are permanent, just like math? If we go down that path, we may ask, how long do we last? We know our physical life on Earth will end, but are we only physical beings? Is there more to us than our physical bodies?